All right. Hi, everyone. I am Lucia Subatin. I work at Google in infrastructure and migrations. I'm very happy to be joining the SAP Online track today, and I'm here with my friend and colleague, Fatima.
Hey, hi everyone. Thank you, Lucia, for the invite. I really appreciate it. My name is Fatima Silveira. I work at Google with Lucia, and I'm also thrilled to join this online talk. My main focus is to help people make the most out of Google Cloud, especially when you're talking about infrastructure, SRE, and app dev.
And that's a great cue for me, as we'll be talking about what it looks like to do SAP application development or app dev, as you say, in the cloud, but with a special component added to the mix, which is an SAP environment. And I feel we're currently representing a great fusion, a fusion of two great worlds, and I'm excited to share this with everyone. So I'm going to start by talking about how the journey starts for my customers. So let's say that someone in a company decides to move their SAP workloads onto the cloud. And I will oversimplify this, like really simplify this. But basically, they will deploy a bunch of virtual machines, maybe run an upgrade, maybe add some business continuity features like high availability, and bam, they have SAP HANA and NetWeaver running on some virtual machines in Google Cloud Platform, or how we call it, GCP.
So, fun nickname, GCP. Sure, but let's say I moved my workloads to the cloud. Now what? Am I cloud native? What do you think?
Yeah, that's again a great cue, because the answer is no. Moving your monolith onto the cloud does not necessarily make it cloud native. So this is called lift and shift. All you're doing is getting your applications as they are on premise and moving them onto the cloud. Technically, inside those applications, nothing really changes. Now, that doesn't mean that SAP is not or doesn't have the ability to become cloud native. So SAP has established some approaches to cloud native development. I am actually known in the SAP community for having built a lot of material around Cloud Foundry or Access Advanced Development, which is SAP's take on Cloud Foundry for on-premise. But in this case, I am talking about workloads that normally take a monolithic approach. And this is not necessarily a bad thing. I'd like to start by saying that SAP has been running for a very long time, and these monoliths, they have also been running steadily and empowering and fueling companies for a very long time. So it's more about changing developers' mindsets into microservices. And again, this is something that SAP has started to do. So you will see a lot of monoliths, but you also start to see some microservices and cloud native development approaches in the SAP world. Does that make sense?
Absolutely. When we're talking about software in general, like we can think of monoliths and microservices as design patterns. They're both valid design patterns. And as you said, monoliths are very stable. Microservices as well. They have to be architected in a way that makes them very stable with a little bit of more care. But in general, it's a good design pattern. Like what I see a lot is one thing you probably want to avoid when you're getting an application that is a current monolith and you think it may be best suited for microservices now because you want more agility and whatnot. So you start migrating your microservices your monolith into a microservice architecture. And then you end up in this kind of middle ground state where you have a sort of tightly coupled microservices, or depending on your point of view, a loosely coupled monolith. It's not that uncommon. It's not that uncommon for applications to end up to being in that state. So that's why when you're pick up the journey, it's really important to have a solid plan that you can take when going down this journey. What do you think?
Yes, I completely agree. And again, this is exactly why I think we make such a great team, you and I, because what I've seen so far is that most companies already have a team that is building microservices in the cloud. And they would actually like to invite the SAP developers into that party, right? And that's how we started, you and I started working together. So I always say that when this happens, the main challenges for those SAP developers are two. First, one is the mindset that they have been applying for years. And I can speak for myself because I started as an ABAP developer. And as an ABAP developer, I was a full stack developer before that even existed, or it was called that way. So I was used to building or understanding in depth the data model that was in my database. And I would build the backend pieces and I will build the front end, even though a lot of that was very simplified by SAP itself, so that the focus for me was the business requirements. And then the second challenge that I can think of and I see is the change in methodology. And by this I mean we're talking about life cycles for this ABAP or RISE of objects that normally take months between the original business requirement and the actual deployment or transport, as we call it, into production. So I know that I have said a lot of different terms and terminology and acronyms here, and that adds to the complexity of the SAP world. But yeah, you can probably confirm that it happens when me as an SAP developer need to face the cloud, and you have the same problem, right? You as a non-SAP native developer, you're faced with this complexity that I was just mentioning.
Absolutely. It's a fascinating ecosystem, but it's quite complex from the outside. So for someone like me, I'm not familiar with SAP at all. Half of the acronyms you just said just flew over my head. I'm not familiar with them. I don't understand. I have to look them up. And I think this is also part of the challenge of a developer that is not specialized in SAP to onboard. SAP has several practices already in place. The rest of the community also has several practices in place, and they are similar. There are several already known concepts that are used in both communities, but in slightly different ways. This means that when a developer that is an SAP developer wants to use the external workflow, or external developer that wants to use the SAP workflow, they have to spend some time learning the specific intricacies of this new workflow. Doesn't matter the direction they're going. And I totally relate with what you said. It's quite fascinating environment, as I said.
That's definitely something we can agree on, and to talk about this complexity, or to counter this complexity. One of the reasons why SAP as a company, as a software company, recommends adopting cloud native development is to actually reduce the complexity. And most importantly, reduce the risk of affecting that monolith I was referring to when implementing new functionality, because we need to bear in mind that we have the blood that runs a company in an SAP system, right? So nobody wants to risk functionality that is already in place. So for example, if you wanted to implement some machine learning in your business logics, you would add a call to an API on SAP Leonardo, which is an implementation of machine learning in SAP Cloud Platform, or an API on Google Cloud, or a mix of both, as opposed to attempting to write a custom Z program in ABAP in that monolithic stack. So this is what SAP means by keep the core clean. And the possibilities to enhance the existing functionality are at least more at hand when you can deploy containers and functions as you please. And this is something we have been working together, right? So you showed me that there's magic in a cloud platform when when we want to expand functionality.
Well, and you showed me there's magic in SAP, which is really cool. But yes, in the cloud platform environment like GCP, it's like absolutely easy to add resources. Like you can just click and then you have a VM, or spin a new container, or even add serverless functions where you don't have to care about the infrastructure at all. It's all at your hand. It's there, right? So this is very flexible. It's very dynamic. But with everything, there is the both sides of the coin, right? With this kind of flexibility, organizations do need a way, a workflow, or more specifically, a development workflow, to ensure they can build velocity over time as their practices in the cloud mature. So the right tooling for this kind of thing is quite important. That's where things like continuous integration and continuous delivery or deployment come in place, like CI/CD pipelines for short, because that's quite a long acronym.
Yeah, that brings me to the next topic, actually, CI/CD pipelines. You just mentioned that. Would you mind giving us a quick intro to what is CI/CD for everyone out there, pretty please?
Absolutely. It's quite a fun topic. I love it. I like to think of a CI/CD pipeline as like an assembly line, but for software. It's a methodology with very well-established steps that help you ensure that the changes you are pushing to your software are well-tested and can be deployed to the correct environment. So I like to write CI/CD as, I like to define CI/CD as two different things, like CI as one portion and CD as the next portion. And it's important to understand that these are quite intertwined. So along your pipeline, you're going to have CI steps and you're going to have CD steps. But the CI steps are responsible for assuring the quality of your services, your software. So think of static analysis, unit tests, functional tests, smokes tests, any tests you're already running, and probably a bit more. And then the CD piece is the delivery or the deployment piece. So there is a little bit of a distinction, which is not that important really, but let's talk about it. So if we're talking about continuous delivery, you really want to ensure that you have artifacts ready to go at any time to any environment. So you're building your artifacts, you make sure they are tested, they are properly tagged. So maybe you have a release candidate tag or a dev route tag, whatever it is that your organization uses. And the artifacts are ready to go. The deployment pipeline, so when you're talking about a continuous deployment pipeline, this is more when the process is fully automated. It doesn't mean delivery cannot be automated. They often have steps between dev and QA that are already automated, and there's like a manual push to prod or a manual approval step. Full deployment pipeline, you can push from dev to prod in a continuous way. And then you can, if you look up some of those cloud native companies, you see they often publish metrics like number of pushes a day or number of prod deploys a day. And that's really only possible because they are using a CI/CD pipeline. Just a quick plug, a CI/CD pipeline usually involves quite a few specific steps. You can think of it logically as a build, a deploy, and a test, or a build, a test, a deploy, and a test, depending on how you're approaching.
Yeah, I think that makes for a great explanation. So thank you for that. And I think that for people out there who are like me, we need to actually see this in action. It's what helped me glue all of the pieces together.
Mm-hmm.
So I think it's showtime. And hopefully everything will fit together nicely if we share one of the pipelines that we have been playing with. So to give a little bit of context for everybody out there, a while ago, Fatima and I published a quick lab explaining people how to create their own microservices to extend SAP functionality using containers. And these are Node.js and Go containers. We did this on purpose so that we could show how flexible these containers can be, because you're building them yourself, basically, and you can bring your own language so that more people can be invited into this party. And we used Google Cloud Run, which a lot of people know is one of my favorite things on Google. Even before I joined Google, I was deploying the cloud application programming model on Google Cloud Run, basically just to see how it worked. So right now we took it to the next level, and we built this example of a web interface interacting with an SAP HANA database using the Node.js drivers for SAP HANA that are built by SAP. And one of these microservices, the backend microservice, is calling a translation API in Google, which is something that is probably useful for everybody out there. So I will not spend too much time on this, as we documented each step so that everybody can do this at home. And if you stay tuned, you can probably do this completely for free, including the deployment of the HANA database and without swiping a credit card. So I'm going away from that application, but it gives some context on what we're doing and where we are applying our CI/CD pipeline. So the other thing I wanted to zoom into, because this is the right audience, is the HANA piece. So we'll see we have an HDI container. HDI containers have been traditionally linked to Access Advanced or Cloud Foundry-based development, but they are technically independent. Tom Young has a lot of great materials around it, showing how you do not even need the Access Advanced or Cloud Foundry layer on top of HANA to have HDI containers. They can be completely separate. And we are using HDI containers because they do have some advantages when doing cloud native applications, as opposed to the classical plain schemas that we used to have before they existed. So the beauty of HDI containers is that developers write design time artifacts, and the HDI deployer, which is a Node.js module, will handle the runtime implementation for the developer. The other benefit that we have is that we can both, Fatima and I, be working on different versions and features of the same schema at the same time, but we can both be using our own copy of the design time and runtime artifacts. So this is similar to having branches in repository, and eventually we will merge them into a master HDI container, so to speak. But as we said before, this is HANA getting incorporated into an existing pipeline. This is in response to what I was saying. I've seen a lot. A company that already has a team doing microservices and cloud native development, and they are inviting the SAP developers over, and they already have their pipelines running. This is different, or would be different, if the SAP team was initiating this on their own, and that is when we would talk about the cloud application programming model, for example. Let's take a look at how that works as a whole. And I think I can pass over the presentation to you, Fatima, so that you can show us the little drawings we've been doing on Jamboard.
So I'll assume everyone can see it. This is the pipeline for the entire application. So it's actually a group of pipelines. And if you can see here, we have our repository in cloud source repositories. Then we have a pipeline here in blue, which is a pipeline dedicated to the Go microservices and does the build for the Go microservices. As part of this pipeline, of course, we have CI and CD steps, which are here on the top. So we have linting, testing, build, and deploying. And the same applies to the other one. So this one is a Go application, and these here are Node.js applications, both of them with their own pipelines. And this is beautiful because I can commit and I can have feature branches for each one of those, and they're going to independently go be deployed into Cloud Run, right? Another thing that is fantastic, and I might add it's because we have the HDI containers, the way that Lucia just explained, it's a really cool design, actually, because the way this thing works, it allows us to have a pipeline here with this for the database, that we have our CI/CD engine here, which is Cloud Build. And all we need to do is have this pipeline open its connection with the right tooling, right, to the HDI container in HANA and run an HDI deploy. So we can now deploy independently each one of these services and your runtime artifacts to the corresponding destination. So in the case of the database, to HANA, the actual HANA database.
Yes, I love your excitement there, because I feel equally excited that we pull this off. And an important note for the SAP development crew is that, unlike a rise of object or a multi-target application, these microservices are completely independent from each other. So they are expected to be developed and tested by different teams, and they have their own time and their own life cycle. And of course, one of the principles in cloud native development is that the contract between these microservices need to be very clear and needs to be very well respected, so that these teams can actually be independent from each other and deploy changes without affecting the other microservices. About the changes that I was mentioning, another difference is that these changes are expected to be more frequent and in smaller incremental iterations in comparison to these month-long development processes that I was talking about before. And this is where automation helps a lot, as it relieves the developer of performing the same tests over and over and potentially getting tired and making mistakes. So what do you think if I switch over to the Cloud Shell and start coding?
Oh, I love the idea. Let's go.
Okay, so I'm here in the Cloud Shell. This is one of my favorite development environments because it can go with me everywhere and everything gets loaded automatically. So I have a lot of tools in the Cloud Shell already available for me. And so one of the tools that we have here is Docker. And I will be showing a lot of cool stuff, including the Docker container that we created for our CI/CD pipeline. But I'm going to start with our application. So as Fatima was showing in the Jamboard, we have the different microservices that comprise our SAP HANA application. We have the database access layer, and we have the database itself. This is very similar to what Web IDE or the Cloud Application Programming Model would deploy in a database module. It has the design time artifacts, like this table that I generated here, that will get deployed into the HDI container by the HDI deployer, which is an Node.js module. And you will see that our microservices here, they have tests included in them. Fatima will go over them and we'll dive into the details of one of these microservices, but it's important to mention that part of having a responsible CI/CD pipeline is to have the tests, and these tests are going to be automated. So this is part of our folder structure. Let's see our Docker container, the one that I was bragging about. I'm going to go ahead and copy and paste a couple of commands here so that you can take a look at our pretty Docker container. So what we did in this Docker container is install the HANA CLI or Tom's CLI, and any other dependency that we need for the deployment to happen automatically and unattended when the time comes. Okay, I need to do a little trick here before this actually works. Here's my symbolic link, and just to show you that I'm real, I'm going to go ahead and connect to a HANA instance. So this HANA instance is a HANA Express database that I deployed on Google Cloud through the marketplace using my own documentation. I had to say that. And one thing, I'll be doing a lot of stuff that you should not be doing at home, like, for example, using the Runtime User to connect directly into the database. The nice thing to do would probably be use my own username with the right permissions granted previously, but this is a demo and I can get away with giving you a disclaimer. Now, if you do not know what this runtime user is about, this is the user that gets automatically generated together with another user that share the responsibility between owning the physical schema and the actual objects within a schema when you're talking about an HDI container. So these users are not necessary when we are deploying a plain schema like we used to in the times of HANA Studio, in the times of Access Classic. But right now, as we said, the beauty of HDI containers is that we have the deployer and we get two users that will manage the HDI container for us. So we do not have any of this. So basically, I use the runtime user to connect to the master HDI container. This is what we're seeing here. So if I do select star from schemas, I should get, if I don't have typos, I should get, whoa, sorry. I was supposed to connect with the CLI. So if I connect using HDB SQL and the same credentials that got stored here when I first connected to the database, and I finally do select star from schemas, I should get the name of the physical schema for my HDI container. And notice how this physical schema doesn't have any additional flags that allow me to have isolation and different versions of my HDI container. This is just run, and run is the name of my schema. Anyways, this is for you to believe me that we do have this Docker container, and I'm going to exit the Docker container and get back to my own Cloud Shell. So I already have this HDI container and I have a master branch, and all of this development that is part of an application comprised of these microservices. And let's say that for whatever the reason, I want to add one more column into a table. Like I have here phrase 2. I added this actually before we started recording. But let's, so that you believe me, let's call it test, because I am very creative today and I have a new column in the table that we saw before. I will need to create my own copy of an HDI container, and I will need to have my own branch for my modifications. I'm going to go ahead and make sure that everything is up to date. Perfect. So I'm going to create a new branch, and I'm going to call that branch online. Let's move into database, see what we have here. Let's try and connect. This time, I'm going to repeat the same database, of course. I got here in my notes. And again, don't try this at home. I'm using the system user, but you should have proper user for yourselves. Now, this container is going to be a copy of this original HDI container that I have, because I'm using basically all of the design time artifacts that I pulled from the master branch, but I need to give it a different name because it's my own version of the container. So I'm calling my container run ls. Great. So now we'll see that default env JSON, hopefully here, is pointing at my new container, run ls, which I have just created. And this is great news. Now we said that this table got modified. We have test, just for the sake of people believing me that I'm making a significant change in our table. I added another column that is called unicorn, because I'm a little obsessed with unicorns. So now I have this changed, and in a normal situation I would be deploying this into my HDI container and actually running tests with my HDI container. So I'm going to go ahead and do npm install, make sure we have all of the modules required by the deployer for package.json. And a little note about this package.json, because we had to modify it in order for it to work in our CI/CD pipeline. So one thing that I'm not sure if we added it or was already there is the auto undeploy. Auto undeploy, I think, was removed in WebIDE the last time I checked, but it allows you to delete artifacts that you delete in the design time. So if I had removed this HDB table and auto undeploy is not here, the table would not get physically removed, because HDI, this deploy.js module, will not do that. So that is what this flag is doing, removing stuff that I remove. And then --exit is actually telling this deployer that after it's finished, it needs to exit, because otherwise it has a message that says this application is ready to finish or something like that. But in the case of our automatic deployment, there's no human there to end our application. So we are ready to call the deployer now. Do npm start. Of course, yes. So there's a thing there that we could not figure out. There's encryption true, even though we tried to tell it not to encrypt. And our HANA Express database is not expecting an SSL connection. So let's try this again. And this looks better. Yes, perfect. So we can see this is the same we would have seen on WebIDE, but it's basically saying I found your modified files and I deployed the changes into your container, the container that we just created for myself. So in normal life, I would be running tests, but what I want to do now is show you how we actually merge the changes in my branch into the master branch. So let's make sure that I add those changes. And I'm going to copy the chunk that says that we're doing this into a new branch that I just created. Great. Now, let's go into Cloud Source. And we see that we are in SAP HANA, but we have a lot of different branches. And this is the one that I just created. but my change isn't there. So let's see, hit commit. Now let's try that push again. And I should see my change now. In the source, the HDB table. And we have the test and the unicorn. So we can see that the actual change is there. And this, of course, makes us very happy, but this is still my branch and where I'm doing my own development. If Fatima wants to use my new HDI container, she won't be able to unless she starts messing with my own branch, and that's not the idea. So I'm going to do some magic here and make sure that we switch back to the master. Fatima may have been doing some modifications, so I want to make sure I have them. I'm up to date. I have a little typo. And this is going to do something very interesting, but I want to make sure that we are in the right place so that you see it in action. This is going to trigger a trigger in Cloud Build. So Cloud Build knows that whenever something gets merged into master, and is related to the database, it will use our container to actually deploy, called the HDI deployer. And this is the trigger that we have. Now, a little note about this trigger. We've been saying that the master has the run HDI container, the master HDI container, and this container is getting fed with the environment variables from VCAP services, because that's what the HDI deployers is looking for. And we have the VCAP services injected right here. It's hard to see because it's not ideal for this format, but you can see we have the HDI password and we have the port and the same false encryption that gave me an error earlier and everything like that. So I'm going to make sure that the trigger gets triggered. We can see it running here, and it's a bit more clear in the history. And here it is, the build of our HDI container. So now, Fatima, how about I pass it over to you and you show us how this is done from any of the microservices that consume the data that is in this HDI container while the build finishes.
Sure. Thank you. That was really cool, actually. So let me quickly share my screen. Okay. So this is the exact same project that Lucia was just working on DAO, on DB. I still have the old version of it. I have not updated, so let's pretend I don't know she worked on it, and I'm going to start from a clean branch. Before I start modifying some of microservices here, let's just wanted to show you this little build folder. This folder has build containers for our pipeline, and really all you need is the Docker file, so you can build it and push into a container registry like the one in the GCP, the GCR. And this is nice because you really want your pipeline to be as fast as possible. So let's say I know I have this static dependency on the translate API. If I was using a Golang, a vanilla Golang container, every time I run a build, I have to download this and install this, then I can run my build. Well, that's time. With a lot of libraries, that adds up. So we can create a build environment for our microservices. And if your microservices don't depend on external things that you gotta download, fine, you just can use the vanilla one. But if you do, like this one, then you should probably create a build image. And as you can see here, just the DB and the translate services have a build image because they require a specialized software that's not in the vanilla containers. So with that said, every service, like Lucia just explained, should be tested. In the pipeline, you really want to make sure you're not pushing through something that doesn't work. So your tests are going to ensure that you can automate your end-to-end flow, right? So let's just poke around the translate service because I was just showing the container for this. But this one has a few tests. We mock up the dependencies and then we test our service independently. Ideally, we should also have, so these are unit tests, but ideally you should also have functional tests that tests the interaction with dependencies. And that can save a lot of heartache on the long run when we talk about microservices and, of course, proper version control. Now, let's go ahead and then make some change on this the service. A better practice would be to pull in changes from master, but I want to simulate we are working about it at the same time, so I'm not going to do it right now. What I'm going to do though is create a new branch. And if you're doing any net new development, you should be using a feature branch and not doing it straight on your master. Let's create something called demo messages, right? So one thing I have into this microservice here is really bad error messages. I'm not even passing the stack error into the console or anything. So I'm going to do a very simple change. But before I do that, good practice before you start coding is make sure your tests are passing, right? So make sure you're starting from a clean environment. So let's just run the tests we have, which are not many. Probably should be more extensive for those production. But yeah, they're passing. Are my tests? All my tests are okay. So now let's make our huge change. Let's test this guy here. And this is really simple, not gonna break anything, but real world tester changes. So let's run tests again. And oh, look at that, I didn't break anything. Surprise. Let's now do the following, right? So one thing that's important to understand now, we are working from a Git branch that's not the master, and this Git branch doesn't have a trigger, like the triggers Lucia was showing just now in the cloud. It doesn't have a trigger attached to it. So me committing it, it's not going to trigger any pipeline. But if you do happen to have requirements for that, you can also make tag or non-master branch triggers that can trigger on any feature branch. Right? So let's now add these changes and commit them. So my super changes. It doesn't like exclamation marks. Okay, so let's push this into our branch. I forgot I gotta do it's a new branch, so I gotta tell the upstream.
The beauty of live coding.
Oh yeah. See. Okay, so now we just pushed our branch. If you list out our branches, are gonna see it's there. Let's go back into master. We're done. Feature complete. Probably the fastest feature that we have ever developed. So check out master. So now is the part. Lucia just finished our changes, committing merging to master. I just finished my changes. I want to merge into master too. Well, before doing anything else, very important, always ensure you are up to date, right? So when even if you don't know someone actually did a change, yes. So now we should have Lucia's change. If we look at the logs, here's her change, right? So let's now merge the changes I've made into master. Yes, and now it's VI. Thank you. And we're ready to push, right? So you can see that we had many additions to the main file. I didn't need to modify the tests. So git push. And now that branch, the master branch, has a trigger that pushes our services into Cloud Run. And we should see it got triggered. So we can see that it's our Go service. And here you have the different steps as we talked about earlier. You can see that we run our unit tests. Well, it's actually running the unit tests. And that's the pipeline. In the end, it's going to push to the Cloud Run, and that's it. So that's it.
That's great. Okay, let's wrap it up and go back to our presentation.
Sure.
Who's presenting?
Hmm?
Who was presenting?
What is presenting?
Oh, there we go.
Well, you saw the Jamboard, right, in the presentation?
Yes.
Okay, sure. I thought I shared something wrong. No, thanks.
So I hope everybody enjoyed that. And thanks again, Fatima, for such good work. It was always a pleasure to build this together. I will leave some references here for now. So we used the HANA CLI, or how we call it, Tom CLI. Hats off to him for open sourcing it, or leaving the code out there, because it definitely makes all of this easier for all of us here. And so there you have the instructions if you want to implement this yourself. And then that is the link to the quick lab that we built with Fatima, and that was the first installment. Our idea is to document everything you've seen in detail, as we said before, and make sure that you can do it at home. And finally, I know everybody is staying at home, and it would be great if we can stay connected. We would love the feedback, and our data is there, our social media is there. So thank you very much for staying with us, and we would love to know what you think.
Thank you, everyone.
Have a good one.